This video is about experiment 30 correction and analysis of liquid sample. The objective of this experiment is to determine the use of water sampling equipment and to correct water sample in field and determine the water quality by measuring the physical parameters including pH, salinity, and dissolved oxygen. Sampling means drawing and samples from populations. In this experiment, water sample will be collected by using a random sampler. The techniques for using random sampler will be demonstrated. During the water sampling, we need to record the date, times, and the weather condition of the sampling points. After the sample collection, we measure the pH, dissolved oxygen, and salinity of the water sample. In this video, the use of pH meter, dissolved oxygen meters, and salinity meter we will demonstrate. For the pH, which is units. For the dissolved oxygen, the unit is milligram per liter. For the salinity, the unit is ppt, part per thousand. The first part of this video is the introduction of water sampler and the technique demonstration. The name of the water sampler is called random sampler. There are two types of configurations of random sampler, horizontal and vertical. The horizontal configuration is used for large lakes or oceans with large depth range, while for the vertical configuration is used for narrow depth range sampling point. This picture shows a vertical configuration random water sampler. We will use the horizontal configuration random sampler for demonstration. The paths for both configurations are similar, include the cylindrical bodies, two end cap with the cable assemblies, the trip mechanisms, and the messenger. After the sample collection, the water sample will fill up into a sample bottles, and the bottle will be labeled with your name, date, location of sampling point. This is a random sampler with horizontal configuration. This random sampler can be used for sampling the water from rivers or ocean with a wider depth. It has similar configuration as the vertical one we just introduced. For this sampler, this is the main body, the cylindrical tube, and with two end caps with drain valve. 19 degrees means closed and 118 degrees means open. The drain valve is used for release the water collected. There is cable assembly attached to the end caps. Two end caps will be opened by putting the cable assembly to the trips mechanism. The trips mechanism will be opened by a messenger. The messenger hits the trips mechanisms. Two end cap close. Water sample is trapped inside the main body. And now the techniques for the random sampler preparation will be demonstrated. Pull out the hand cap. Hold the cable inside the pins of the trip mechanism. Pull out another end caps and hold the cables. And now the random sampler is ready for sampling water. Before putting the sampler into water, the simulations for opening the end caps will be demonstrated. The depth of the sampling point is dependent on the length of the sampling line. Place the sample line into the water with desirable depth. Strike the line. Release the messenger to hit the TRIPS mechanism to close the end cap. And then retrieve the sampler from the water. And we will use the blue brackets to store the water sample and simulate how to collect the water sample from river. Before putting the sampler into the water body, make sure all the valves are closed. To secure two cables on the trip mechanism pins. Place the random sampler inside the water body. Release the line to adjust the depth. When the sampler reaches the desirable depth, rinse the water sampler 3 times. After that, straighten the line, release the messenger, and the messenger will hit the TRIPS mechanism and the end cap close. Retrieve the sampler. And now discharge the sample into the sample bottle through the valve. But to label the sample bottle with the sampling details, include the date, times, radar. Open two valves to balance the pressure. Rinse the sample bottle with the water sample. And the water sample is now for testing. This is the end of the demonstration of the technique for using a vendor sampler. This is the sampling detail, which we just mentioned should be put on the sampling bottles, include the dates, type, radars, and possible sources of pollution. Those parameters are very important for environmental analysis. Many parameters vary during the days, so we need to record the type of sampling. Weather condition is an important factor for analysis the data. During the rainy days, sample may be diluted by the rain. Possible source of pollution of the sampling ponds should be observed during the sampling. In this part, the pH of the water sample will be measured. The pH of the sample will be measured by a pH meter. pH is a measurement of the hydrogen ion concentration. It is a measure of the relative acidity or basicity of the sample. In a neutral solution, the pH equal to 7. For acidic solution, the pH is less than 7. For a basic solution, the pH is larger than 7. For unpolluted freshwater samples, the pH usually between 4 to 8. The pH of the water is important for the aquatic living things. Some molecules, such as proteins, will be lost their functions if the pH away from the optimum one. For the use of pH meters, there are two main steps. The first one is the calibration. We need to conduct the calibration before the second step measurement if the pH meter is idle for a long time. During the calibration process, two buffer solution will be used. For the acidic sample, the pH 7 and pH 4 buffer will be used. For alkaline samples, during the calibration, pH 7 and pH 10 buffer will be used. Now is the demonstration of pH measurement. This is the seawater sample collected from the Victoria Harbour. The water sample is stored in a sample bottle. For the pH measurement, use a clean beaker as a container for pH measurement. Rinse the cleaned beaker with the sample solution. Remove the deionized water inside the beakers to prevent the dilution. Collect about 15 ml of sample water for pH measurement. To label the beakers. This is a pH meter used for measuring the pH of the seawater sample we just collected. Different models of pH meter may have different interface, but for use of pH meter, there have to be two steps. First step is the calibration, and the second step is the measurement. When the pH meter connects to the power source, it takes time for the system ready. And now is the steps for the calibration. Before the calibration, I would like to introduce the parts of the pH meter, the main control panels. This is the button for calibration. This is the confirm button, CFM. We need to press these two buttons during the calibration procedure according to the display. And this is the pH readings. You can see the pH, and now it's 7.42. And this pH is the solution where the pulp is placed. According to the previous calibration, the temperature is measured by the thermometer, which is a thermocouple. The pH value is temperature dependent. And this is the electrode for the pH measurement. It is a glass electrode which is fragile. There is a reference electrode inside the probe. The electrolyte used is the saturated KCl solution. The electrode potential of the probe depends on the condition of the boundary of the glass and the solution inside the probe. The calibration have to be conducted if the pH meter is switched off or long times idle, as the condition of the probe may change. The liquid level inside the electrode will be lower if the glass is dry. That's why we have to place the electrode inside the DI water when it's idle. If the liquid level changes, the electrode potential of the probe also changes. The electrode potential of the probe is also a function of the hydrogen ion concentration of the solutions where the electrode plays in. When the condition of the electrode is steady, the electrode potential is proportional to the concentration of hydrogen ion. That's the theory of the pH measurement. These are two buffer solutions. Their pH have little change when small amount of strong acid or base added in it. The pH of the buffer solution can be adjusted by mixing different ratios of conjugated acid and base pair. Most of the buffer solution is colorless. The color is added into the buffer solution to distinguish two pH. The coloring reagent will not change the pH of the buffer. During the calibration process, the electrode and the thermocouple will be placed inside the pH 7 buffer. The potential will be recorded by the instrument. After that, place the electrode into the pH 4 buffer. Another potential will be recorded. Two data points will be used for construct the internal calibration curve. The sample measurement, the pH will be gathered by substituting the electrode potential of the solution into the calibration curve automatically. Okay, let's start the calibration procedure. For different pH meter, there will be 2-point calibration, which means use two buffer solution, or 3-point calibration. The buffer solution with pH 7 is essential for all calibration. If the sample is acidic in nature, we will use pH 7 and pH 4 because the pH of the sample have to be within the range of these two numbers. If the pH of the sample solution is alkaline, we will change the buffer solution to pH 7 and pH 10. For the calibration procedure, we need to change the mode to calibration mode by pressing the button CAL. The display will be changed once the button is pressed. You will notice that there's the CAL icons, pH, and BUF means buffer. And the pH of the buffer required, which is 7.01. Before placing the probe into the buffer solution, rinse the probe with deionized water. Remember that the glass probe is fragile. Clean the glass probe with the lens paper slowly to remove the surface water. Every time when you change the solution, you have to rinse the probes and clean the surface water again. Strain the buffer solution before placing the electrode to homogenize the mixture. Use the glass probe as a stirrer. And then add the thermocouple into the buffer solution. Before that, we need to rinse the thermocouples with deionized water and water with the lens paper. Put the thermocouple inside the buffer solution. The instrument will measure the potential continuously until it gets steady. Once the potential measurement is steady, a ready icon will be indicated, and we need to confirm the result by pressing the button CFM. After pressing the confirm button, the display changes. The pH of the buffer solution required is 4. Place the probe and the thermocouple into the buffer with pH 4. Before that, rinse the pulp and the thermocouple with deionized water, and then clean the surface water with the lens paper again. Place the pulp and the thermocouple into the buffer solution with pH 4. Strain the bottles to mix well the content. Wait until the potential measurement becomes steady. Once the ready icon is indicated, press the CFM buttons again, and the display is changed. There's no CAL icon means the calibration process finished, and this is the measurement mode of. And now the calibration process is complete. Let's move the electrode and thermocouple into the sample solution. Before that, remember to rinse the electrode and thermocouples again and remove the surface water to prevent the dilution of the sample. Place the electrode and thermocouple inside the seawater sample. This is the pH and the temperature of the sample. As you can see, the reading is keep changing. We need to wait until the reading gets steady. It takes time. After 4 minutes ratings, the readings did not change within 15 seconds. We could regard the reading is steady. We can take our readings. And for the pH, which is 5.8, and the temperature of the sample is 13.8 degrees Celsius. After the measurement, remember to rinse the electrode and thermocouple with deionized water. Place the electrode into a bottle contains deionized water. Clean the thermocouple with the lens paper. This is the end of the pH measurement. After the measurement, let's write down our results. The pH of the sample was 5.81 and the temperature of the sample was 20.8 degrees Celsius. Now let's move to the salinity measurement. The salinity means the concentration of the dissolved solid in water. Salinity can be expressed as gram per kilogram, g per kg, or part per thousand. Salinity meter can be measured the conductivity of the water, which is proportional to the concentration of the dissolved solid. There are other methods for measuring the salinity. For example, use the refractometer to measure the refractive index of a series of sodium chloride standard solution. For a salinity meter or a conductivity meter, it has to be calibrated before use. The calibration solution used is 0.01 molar KCl solution. After the calibration, we can conduct the sample measurement. As the pulse of the salinity meter is much more stable than the pulse of the pH meter, routine calibration of a salinity meter is not required. The calibration of the salinity meter will be skipped in this video. This is a salinity meter or conductivity meter which is used for measuring the salinity of the water sample. There's a huge difference between the seawater and freshwater. For the seawater sample, it contains lots of sodium chloride. For the freshwater, the salinity should be 0. During the dissolved oxygen measurement, the parameter of salinity have to be entered to the instrument, so that we have to measure the salinity before measuring the dissolved oxygen. This is the salinity meter. For more accurate speaking, it should call conductivity meter. The conductivity of the sample will be measured, and the conductivity of the solution is proportional to the amounts of the dissolved salt. 0.01 m's of potassium chloride solution is used as standard solution for the calibration, as the solution has specific resistance. And let me introduce the conductivity meter. And this is the control panel. And this is the probe for measuring the conductivity. When proceeding the calibration process, press the CAL buttons. It will change the mode to calibration. As mentioned before, the electrode is stable, so the routine calibration is not required. The functions of a conductivity meter is not limited to measure the salinity. You can change the mode. By press the mode button to measure other parameters. And now is the mode for measuring the salinity. As you can see, the SAL and the unit with PPT. PPT means part per thousand. It means that for 1 kilograms of water sample, which contains 1 gram of dissolved salt. Same as the pH measurement, it would measure the temperature of the sample also. When we want to use the conductivity meter, just press the on and off button. And now I will introduce the probe of the conductivity meter. Conductivity will be measured start from the tip to the holes of the probe. That's why the whole pop should be immersed into the sample that being measured. It requires a certain depth of the water sample. That's why we place the seawater sample inside a large reagent bottles, and then we put the probe inside the bottles. Before placing the probe into the water sample, we need to rinse the probe with deionized water. We need to clean the whole probe, start from the hole to the tips of the probe, and then remove the surface water with the lens paper. As you can see, the reagent bottle is full of the seawater sample, and then we put the cleaned probe into the water sample. Make sure there's no surface water attached on the probe. Make sure that the probe is fully immersed inside the water sample. And now we can take the readings for the salinity. Let's take the readings for salinity and the temperature of the water sample. According to the measurement, let's mark down the results for the salinity. The salinity of the water sample was 27.9 ppts and the temperature of the sample was 21.1 degrees Celsius. And now let's move to the final parts of the experiment 30, dissolved oxygen and the dissolved oxygen meter. Dissolved oxygen, DO in salts, means the amount of oxygen dissolved into water. Dissolved oxygen is an important factor for most of aquatic organisms. For aquatic organisms, it dies if the dissolved oxygen level is too low. Dissolved oxygen is the key task in the water pollution and wastewater treatment process control. Lower dissolved oxygen level means pollution caused by the organic discharge. The unit of dissolved oxygen is milligram per liter. Dissolved oxygen is measured by dissolved oxygen meter. There are also two steps for using a dissolved oxygen meter, includes the calibration and measurement. Let's start the dissolved oxygen measurement. This is a dissolved oxygen meter for measuring the dissolved oxygen. This is the control panel for dissolved oxygen meter, and this is the electrode for dissolved oxygen measurement. I will introduce the buttons for the control panels. This is the function switch, and this is the pointer. For the calibration procedure, we need to set 0 without any water sample, and then switch to the percentage for saturation. For setting 0, just adjust this button. After setting 0, switch to the percentage for saturation. During the measurement, we need to stir the water sample by turning on the stirrer. For either measurement or the calibration, we need to adjust the salinity. For the calibration process, the salinity should be 0. For setting 0, place the electrode into an empty BOD bottle. Set the function switch to 0. Check that the salinity log is set at 0. As there's no water inside the BOD bottle, salinity should be 0. When the salinity knot is set at 0 and the main switch at 0, adjust the display to reach 0.00. Set the function switch to percentage mode. Place the electrode in a BOD bottle contains about 1 inch of water to provide 100% relative humidity calibration environment. Fill the BOD bottle with the ionized water and place back the electrodes into the BOD bottle. And adjust the display to 100%. And adjust the reading. Adjust the display to 100%. As you can see, the reading is dropping. Adjust the loss slowly until it reaches 100%. The fluctuation of the readings indicates the Austrian membrane getting older. The knot can be adjusted clockwise or anti-clockwise to get the numbers reach 100%. As the fluctuation getting small and all the number is around 100%, it means settings for saturation is finished. You need to lock the lock after setting 100% and change for the sample measurement. Fill the sample water into a BOD bottle. The BOD bottle means biological Austrian demand bottle, which with a desirable 300 milliliters in volume. When filling the sample into the BOD bottle, minimize the formations of gas bubble. Open the valve slowly. Fill the water along the inner wall of the BOD bottle to prevent the bubble formation. Add the sample into the BOD bottle to full. Place the tray under the BOD bottle containing the sample water. The water sample will leach out when insert the electrode inside the sample bottle. Insert the electrode into the BOD bottle. Make sure no gas bubble trapped inside the BOD bottle. And then set the salinity of the water sample. The salinity of the water sample was about 28 ppt. Turn on the stirrer. After turn on the stirrer and setting the correct salinity of the sample, and now we can take the readings of dissolved Austrian. Set the function switch to the units of dissolved Austrian, mg per liter. The reading of dissolved oxygen can be recorded as 2 decimal places or 1 decimal places. It depends on the amounts of dissolved oxygen. And the readings for dissolved oxygen is about 6.6 something milligram per liter. Similar as the balance for the reading with 2 decimal places, the reading always fluctuates for the second decimal place. For recording the reading, just choose the numbers that occurs most frequently. With a high level of dissolved oxygen, we can take the reading as 1 decimal place. By setting the function switch to 0.1 milligram per liter, and now the readings for dissolved oxygen of the sample is 6.6 milligram per liter. For dissolved oxygen, we need to record the temperature of the sample also. Just set the function switch to the temperature, and this the readings of the temperature of the sample. And the measurement of dissolved oxygen is complete. Turn off the stirrer and discharge the sample solution. And after the measurement, just write down the records in the table. The amount of dissolved oxygen in this seawater sample was 6.6 milligram per liter, and the temperature of the sample is 21 degrees Celsius. This is the end of the video.